The next intermolecular force we're going to talk about is dispersion. And the idea of a dispersion intermolecular force came about when we realized that even nonpolar molecules must have some kind of intermolecular force. And a good example of this is helium, where at room temperature it's a gas, but if we cool helium down enough, it'll actually become a liquid. Because it becomes a liquid, it implies there has to be some type of intermolecular force inside of helium, despite the fact that helium is technically nonpolar. So how do we get a dispersion intermolecular force? Nonpolar molecules are surrounded by an electron cloud. And what happens is these electrons want to stay as far away from each other as possible, but because they are moving at such high velocity, there's this slight probability that the electrons will shift to one side of the molecule, and in doing that, it will create a very momentary dipole inside of that molecule. And with that, when you form a dipole, there's going to be an intermolecular force. So this slight intermolecular force is called dispersion, when we get the electron cloud of a molecule shifting to one side and not the other. So it's a little bit easier to see when we look at this example. Here we have a helium atom. Helium has two electrons, and those two electrons, because they're both negatively charged, repel against each other. So they want to be as far away from each other as possible inside of the helium. Because the electrons are moving with such high velocity, there is this slight probability that the electrons could crowd to one side of the helium atom. And in doing that, the one side of the helium atom will get a slight negative charge, because both negatively charged electrons are on one side. This side of the helium atom will get a negative charge. And then on this side, we have protons inside of the nucleus. That'll cause the other side to have a slight positive charge. Overall, this creates a polarized helium. So polarized means we have a slight negative on one side and a slight positive on the other side. So just like polar molecules, the positive from one helium atom can react with the negative on another helium atom and create a very weak interaction that we call dispersion. So in the next section, we're going to compare all the four intermolecular forces and compare them with each other and say which one's the strongest, which one's the weakest. But with the dispersion intermolecular force, we can actually compare two different molecules with a dispersion force. We can say which one has the stronger dispersion intermolecular force. The rule is, as a molecule becomes bigger, as its molecular weight increases, it also has more electrons. As the electron cloud around the molecule increases, we increase the chance that those electrons can crowd to one side of the molecule and not the other. Because we increase the chance of this crowding to occur, we also increase the dispersion intermolecular force. So the rule is, as a molecular weight of a molecule increases, the number of electrons in the electron cloud increases, and this causes our dispersion intermolecular force to also increase. So here's an example where I give you three different molecules that all have dispersion intermolecular forces as its strongest intermolecular force. And I'm asking which one has the highest melting point. And that's kind of like saying which one do you expect to have the strongest intermolecular force. To find out which one of these molecules has the highest melting point, we need to look at the molecular weight of each molecule. If you go to the periodic table, iodine actually has the highest molecular weight of 254 grams per mole. Bromine is 160 grams per mole, and chlorine is 71 grams per mole. Of these three, iodine has the greatest molecular weight, so it will have the greatest dispersion intermolecular force, and it will most likely have the highest melting point. Likewise, chlorine is the smallest, so it should have the lowest melting point. And this is true when you go and you look it up. Iodine has the largest melting point of 113.5 degrees C. Bromine is next at negative 17.5 degrees C, and chlorine has the lowest melting point of negative 101 degrees C. And you can also see this by looking at these molecules at ambient temperature. So at normal room temperature, chlorine is a gas, bromine is a liquid, and iodine is a solid. That's because the iodine has the greatest intermolecular force or greatest dispersion force.